pendulum. You use pendulums in physics a lot because they help keep us time. We can do measurements on them. So the pendulum, just like a grandfather clock, swings back and forth. So what we're doing is a snapshot. We're taking a snapshot of when the pendulum has swung out to the side. Okay, and that gives us a right triangle. So this is 90 degrees. Mark that on your diagram. Okay, and then what we want to do is understand how this diagram what the different pieces. So the length of the pendulum can be in two spots. It can be here and also there. Okay. Now this is the rise. Okay. Now the rise can also be right here. So we could do a subtraction to find x. Okay, or back and forth. Once we find x, we can subtract the length to get the rise. So our rise equals the length, entire distance, minus the top, which is x. Okay. Here at the very top we have the angle of swing. So sometimes we want to find that, other times they give that to us. Okay. This is the position of the pendulum at rest. Okay. And this is the swing position. Any questions? Okay, so a pendulum is 65 centimeters long, swings out 35 degrees. Underline, underline. How much has the little pendulum been lifted? So you want to find the rise. Start by drawing a diagram. There's the pendulum at rest. There's the pendulum swung out. And then you can draw your dashed line to get your triangle. Okay, place those numbers in the right spot. Go. So the 65 is tricky. It should go in both spots. This here will be 35 degrees. So what we want to do is we want to use our triangle to find x. Then we can find y by doing subtraction. So go ahead, do SOHCAHTOA to find x. Go. So 53.24, and so you want to subtract 65 minus 53.24, and what does that equal? 11.75. So we'll round to one decimal. 11.8 centimeters is the rise. Okay, nice, neat, tidy. So next we have the clinometer. This is what you want to look at for your trigonometry project. Trigonometry project. So just Google clinometer and I'll show you by putting these in the right spot. One thing to note is that this angle right here, 35 degrees, it looks not like that. It has nothing to do with that at all. This angle almost matches this one perfectly. That's what you're measuring. You're measuring the top angle. It doesn't even line up close there. So you have to know that that is where you're measuring. Okay? So this angle, 35 degrees, belongs at the top. Okay. Now the clinometer is 1.5 meters. That means his eye level is 1.5 meters above the ground. So right over here on the tree, that's also 1.5 meters. That's where the triangle starts, 1.5 meters above the ground. Billy's 5 meters away, okay, and that's the bottom of the triangle. So what we're trying to do is find x in our triangle, so then we can add 1.5 and find y. Okay, so within the triangle, find x, then find y by adding. Go ahead, find x. So you should use tangent. X equals 7.14, and so y equals x plus 1.5. So 8.64. So tree is 8.6 meters tall. Okay, very short, quick, and easy. Any questions? All right. Turn it over. Polygons. Okay. So what we want to do is divide a polygon into triangles. All triangles from the very center, you can divide all polygons rather into triangles. They'll all be equal. Now, I've got, my drawing doesn't look yet, but those are all equal triangles. So what we need is an angle. We know that all the way around a circle is 360 degrees. So what is one small section? Come on in. Okay, so for this angle here, it'd be 360 divided by 1, 2, 3. There's 5 equal pieces. So divide it by 5. I believe that's 72 degrees. Okay? But still, we can't find the area of the triangle. And we can't use SOHCAHTOA because we have no right angles. Any ideas? Okay, keep in mind, those are all 18 meters. Okay. Also keep in mind that these lengths are equal as well. What kind of triangle is this now? Isosceles. We did a question with isosceles triangle, a roof. Remember the roof question? What do we do to that triangle? Well, we drop down an imaginary height. So what that does is that splits 18 into 2 equal pieces. It also splits the angle into 2 equal angles. So let's draw one little small triangle. What would be the bottom measurement? Good. And what would be the angle? 36. 72 divided by 2. Okay. So what do we need to do in order to find the area? We've got to find the area of this triangle. How are we going to do that? SOHCAHTOA to do what? To find the hypotenuse? So no. Remember a triangle, area equals base times height divided by 2. And B and H join at what angle? 90 degrees. So what we have to do is find x. Okay? So do SOHCAHTOA to find x. So x equals 12.387. Now don't erase that from your calculators. Okay. What we want to do then is find the area of that small triangle. Okay. So area equals base times height divided by 2. So area is going to be 9 times 12.387 dot dot dot, all those numbers divided by 2. So for one small triangle, now I have all my decimals, so use them. Use all your decimals, times it by 9, and then divide it by 2. 55.74. Okay. And let's go 7434. All right. Now, how many small triangles are in there? I thought there's 5. Who's right, me or Ashley? Why am I saying 5? Because I'm looking at the big triangles. I'm making a mistake. We didn't find, we didn't find the area of this triangle. No, we didn't find the area of that triangle. We found the area of this triangle. Okay, so what I have to do is then divide them all up. And so Ashley is correct. Okay, so times this by 10 because there's 10 triangles. Number of small triangles. Okay. Yep. So times it by 10 is still in your calculator. And 557.4 meters squared. Okay. I'll give you a hexagon, an octagon, or a decagon. Okay, so this would be 6, 8, or 10, or another one, right? Nanagon, something like that. Okay, so this would just change the angle and the number of triangles. Okay, so when I give you a different shape, you just got to be careful with that. Okay. All right. Please read the question. Next one. Okay, so this one is really interesting. This one is like the Manitoba legislature building. Write this down. So when you come to that question in your textbook, you want to draw a diagram just like that. Now don't draw a tower. What you're going to do is just use the same diagram, just like I just did. But this would be Tegan, and that would be Janelle. Okay, so that's where the people are standing. But just draw the diagram, then start putting the numbers on there. Okay, without the diagram, it's really, really hard. But with the diagram, it's super easy. Okay, so just replicate the diagram. Now for this one, if I gave this to you on a test or a quiz, I'd give you the diagram, and then you can put the numbers on. Okay, so I wouldn't do it completely blank. Okay. So what's interesting is that this triangle is 90 degrees because we're talking about the ground. This is the ground plus a tower. All buildings go up at 90 unless it's the Leaning Tower of Pisa. This is also 90 degrees, the ground and the tower. Now the fires are on the ground. And because one's due south and due west, they're also at 90 degrees. So you have 3 triangles. Now this question isn't like your textbook. Your textbook is going to ask for x, it's going to ask for y, and then it'll say, well, what's the distance between w? This question just asks for w right away. Okay, that's pretty challenging. So, a couple things to remember. This angle of depression, 5 degrees at the top, is also the same as the angle of elevation at the bottom. That's important. Same thing with the other triangle. Angle of depression of 2 degrees at the top is the same as 2 degrees on the bottom. So, what we're going to do is find x and y. Let me just draw their triangles out here, though. So this is 5 degrees and x, and 90 is the height of the tower. For the other triangle, 90 is the height of the tower. They share that. This is y, and this is 2 degrees. Okay. So, up top over here, please find x, and please find y. Now, keep the numbers in your calculator. Use your memory button to help you. Okay, so just press M+, and it will be stored in your memory. So we're going to have to use a tangent function. Okay, so there's x, 1028.704. Okay, so what we're going to do is plus memory store, or m plus. Okay, then I'll go and calculate y. So y is 2577.2627. Or 262. Okay, so you should keep everything. Good. Now what are we going to do for w? How are we going to solve that? You know x and y. What do we do with our right triangles? Yeah, Pythagoras. So x squared plus y squared. That's why I wanted to keep the numbers in the calculator. So for me, I'll just square this, and then I'll add, recall my memory, square it, that's x squared, press equals. So w squared should be 770015, sorry, 516. Question, Michaela? Let's see, hold up the calculator. Bring it up. It should be RCL. Yeah. RCL. Some of them, let's see, like, just say, come here, bring here. Like Prab jokes, you have to press like recall 1 and store 1 and stuff.
Because there's an M up there, but now there's an RCL up there too.
What's in your memory, do you know? Yeah, keep your instructions. You can also Google it and figure out how to use it, okay?
Okay.
Because this just looks like your memory button here.
Yeah. I pressed it.
So 02 plus. That might bring it back up.
Okay.
I'm not sure. Because sometimes calculators have 3 memory buttons. You're going to have to Google it. Okay, I'm not too sure. So just type in the staples and then the number, and all your instructions will come up. Okay? Okay. So once you have them all out, yeah, if you've lost your instructions, Google them. Right? Type in the branded calculator and the model number, and it'll come up. And you want to know how to use your memory. Okay? A lot of you have the A and S. That brings up the last answer. That's really good too. Okay, and square root this. 2774.908. Sorry, 0.998. So then you can say the fires are 2,775 meters apart. Okay, so they're really close to 3 kilometers. Okay, so your homework for today, number 1 is a worksheet that I'm going to hand out. You'll want to get started on that right away and only do page 118, not page 124. Okay, that's going to be review, but you just have the worksheet and page 118. Okay.